So this is what they say to us in this case. After traveling a distance of 20 kilometers from home, a person suddenly realized that he didn't close the tap in his garden. So he decides to turn around immediately and return home to close the tap. The cost of water at the rate at which water is flowing out of the tap is 1 rand 60 cents per hour, and the cost of petrol is 1.2 plus X over 4,000 rands per kilometers, where X is the average speed in kilometers per hour. So the question to us is, calculate the average speed at which the person must travel home in order to keep his cost as low as possible, right? So in other words, calculate the value of X for which the cost will be a minimum. So before we can get into calculations, before we can do anything, we need to analyze this situation nicely, right? So here, the first thing we realize is the function that we are working with is the cost function. This is the function we are busy trying to minimize. And another thing we are realizing is we are minimizing the cost in terms of X, right? So in other words, our cost is going to be the function of X. So this is what we realize. Now, another thing that we realize is the fact that even though this person traveled from home to the point at which he realized, and then he moved from this point back to home, even though we understand that the total distance he traveled is actually 20 times 2, which is 40, the question itself is not interested in the entire motion. They just want to know from the point at which he realized up until he went back home. In other words, we are only interested in a one-way motion of the entire motion. Now that's fine. So now seeing what we see then, we can now go ahead and try to find the value of X. But now since we understand that we are minimizing the cost function, then this is how we get the total cost, right? So the total cost is going to be the cost of the water plus the cost of petrol. Are you fine with that? But now here you realize the most important thing. It's the fact that we are given the cost as a rate. So for this one is the cost per hour, right? So in simpler terms, we can just say this cost is expressed in rands per hour. And of course, we understand that the hour is just the time. Okay, that's fine. But now if we get to this one, the cost for petrol, well, here we realize that this cost is given to us as a rate as well, but it's in rands per kilometers. And to be honest with you, this is not the cost and this is not the cost, but those are just the rates. So we need to find the actual cost of the water and the actual cost of petrol. So the question is, how do we get the actual cost? Well, the easiest answer is if we can eliminate time here, and here we eliminate the distance, then what is remaining is the rands, which is simply the cost, right? Okay, what am I saying in simple language? Well, this is what I'm saying. If we can come to this part and multiply it by time, And then we come to this part and multiply it by the distance. You can call it x if you like. Then we are now going to get the actual costs, right? Okay, fine. Now the question is, how do we eliminate the time from the first one? Well, it's very easy. We remember from grade 1 that speed is distance over time, right? Of course we do. So this is what we say. But we remember that the speed is x, and the distance that this person travels home, it's just going to be 20 kilometers, and this is divided by the time. And if we want to make the time to be the subject of the formula, well, we just take what is the subject and make it the denominator. So this is what we have. Of course, if you like, you can begin by cross-multiplying and then divide on both sides. You'll still get to this conclusion. So in simpler terms, this is what I'm trying to say to you. In order to get the total cost, what is the cost as a function of, in fact, as a rate? Well, the cost of water is 1.60 rand per hour. And of course, we understand that our speed is in kilometers per hour. So meaning our time here is actually in hours, right? So we take this rands per hour and multiply it by the time, which is in hours. So the hour will cancel the hour in the denominator. And so we are left with the rands, which is just the cost itself. Get it? Then we say plus, we go to this one, all right? Then we say, well, the cost as a rate is 1.2 plus x over 4,000. Now the question is, how do we get rid of the kilometers? Because here we understand it's rands per kilometer. How do we destroy this? Well, by multiplying it by the distance, right? So the question is, what is the distance? Well, the distance is just going to be 20. So that's what you will say. So 20 kilometers will actually cancel out with the kilometers in the denominator. And this is what we will have. Okay, fine. So what? So now we can see clearly we have our cost as a function of x. And now what we need to do is just to simplify this function and then minimize it. So, well, if you say 1.6 times 20, well, you're simply going to get 32 divided by x, right? Okay, that's fine. And then we say plus. So here we are going to distribute the 20. So 20 times this, 20 times that one, okay? So once again, we get 32 here. And then here we have x divided by what? Well, if you say 20 divided by 4,000, you are simply going to get 1 over 200. Because it's going to be 20x divided by 4,000, all right? And of course, we know that it's possible to simplify this further. So that is what we said. But of course, we understand that 4 can be written as 2 by 2. And so what we can say here is 20 and 20 will cancel out. Wait, what am I doing? There's supposed to be another 0 there because 2 by 2, it's just 4. So it's 4,000. So when the 20s cancel out, we are just left with 200. In case you had to do it without a calculator. Okay, fine. So this is what we have. So now that we have our cost function, then what we need to do is to differentiate this, equate the derivative to 0, and then solve for x, right? Okay, fine. But of course, we know that according to the power rule, before we can differentiate, we need to make sure that, what is it we need to make sure of? Well, we need to make sure that our variable is not in the denominator. So we need to write this nicely first. And of course, this is something we could have done at this stage and write it as 32x to the negative 1, because the rules of differentiation say everyone has to be ready first. So now at this point, we are very much safe to differentiate the function. So what is the derivative of this? Well, it's simply going to be negative 32x to the negative 2, right? But since you understand how I got this, I think it makes sense for me to write it as a final answer, right? And just say it's negative 32 divided by x squared. And 32 is just a constant, and the derivative of a constant is 0. Then what about this one? Well, x over 200 is exactly the same as 1 over 200 times x, which is the same as 2x, right? Why am I comparing it with the 2x? Just want you to realize that 1 over 200 is a constant. It's a coefficient of x. And the derivative of 2x is 2. So which means the derivative of 1 over 200x is simply going to be 1 over 200. So yeah, this is what you're going to say, right? Okay, fine. Then what do you say from this point? Well, it's very easy. You're going to equate your derivative to 0. So you'll say 0 is equal to negative 32 over x squared. And then you say plus 1 over 200, right? Well, this is what you're going to say. But since you understand that we have to take this one to the left-hand side so that it becomes positive, then it means quite simply, this is what we are going to have on the right-hand side. Oh, we actually have 32 over x squared. And this is equal to 1 divided by 200, okay? Okay, fine. So now we need to solve for x. Well, the easiest thing we can do is to cross multiply. So we say numerator times denominator. And then we come back again and say numerator times denominator. So the question is, what do we get? Well, 1 times x squared is x squared. And what about 32 times 200? Well, it's just going to give you 6,400, okay? Because 32 times 2, it's 64. And then you still add those two zeros. So now it's time for us to find the square roots on both sides. So this is what we say, okay? And you're not going to say x is plus or minus. Why? Why can't we not say minus? Did you listen to what I said? I said, why can't we not? Imagine. I wanted to say, why can we not say x is plus or minus square root that? Well, it's because x is the speed, and the speed cannot be negative, so it has to be positive. Now the question is, what is the square root of 6400? Well, it's easy. You just come and say, what is square root 64? Well, the square root of 64 is 8. And what is the square root of 0? Well, the square root of 2 zeros is just 1 0. And then you say, well, this is just going to be in kilometers per hour. So this is how you find your speed, okay? Right. So now if you are in high school, you are actually done. So you can just leave this video. It's okay. You have watched it to the end. Thank you so much. So now it's time to speak with the adults. So let's say you are in university and of course you are doing the actual calculus, not differential calculus. So how do you proceed from here? Well, it's very easy, right? Because you understand that saying this is actually not enough. You need to convince us that this value of x actually occurs at the absolute minimum. And in order for you to convince us, you need to use the first derivative test for extreme values. So what are you going to say then? Well, this is what you will say. And of course, if you are in varsity, you understand that as soon as you have defined your cost function, you need to state the domain of that function as well, right? So I'm just going to get rid of this part. So the question is, what is the domain of this function? Remember, 32x to the negative 1 is just 32 over x squared, okay? So what is the domain of this function? Well, here you can see that any value of x that is greater than 0 will make sure that the function is defined. And in fact, it's the truth because the speed has to be greater than 0. How can you return home with a speed of 0? So that's the domain of the function. So now it's time to convince them that indeed we are at the absolute minimum. So how do we do that? Well, it's easy. So we are going to go to our number line. In fact, our sign line. Yeah, it's the sign line. So this is how the sign line is going to look like. And this is what we say. We say, well, we have our x, which is 80 there. So what we need to do here is to observe the behavior of the derivative of this cost function, all right? And we remember that our cost, or rather the derivative of the cost function, is actually negative 32 over x squared. And then we say plus 1 over 200. That's fine. And it's actually in its simplest form, so we can't really factor or rather simplify it any further. No, except by, I don't know, but no, we don't need to do anything. It's perfectly fine. So what are we doing here? We are looking for the values of, or rather we need to pick any value of x that we like, which is less than 80, as well as greater than 80, so that we can see if the derivative changes the sign, right? Well, any value of x that is less than 80, the simplest one you can choose is 1. You can choose 1. So you come and substitute your 1 into the derivative of the cost function. So 1 squared is 1 and 32 over 1, it's negative 32. And if you say negative 32 plus 1 over 200, what is the answer going to be? Well, we are not interested in the answer, but rather in the sign of that answer, okay? Well, 1 over 200 is definitely a very small number. So it's about 0.00 something or We don't know, but it's definitely small. We don't even need to find the exact value of it. So anything that is very large being negative, added to something that is very, very small, it's going to give us a negative result. So this is what you will say. So now we need to choose any value of x that is greater than 80. Now the question is, what is the easiest value we can choose? Well, let's choose 100, just for control. So what is 100 squared? Well, you are just going to have negative 32. So if you say 100 squared, you are simply going to get 10,000, okay? So here you have 10,000, and you want to add it to 1 over 200. So the question is, between these two, which one is the smallest? That's a very, very good question. Well, right away, we can see that this one is the smallest because it's not 32 over 1,000 or what, it's 10,000. But if you wanted to simplify it further so that you can actually see it clearly, you can simply say 32 is the same as 16 times 2, and 10,000 is the same as 5,000 times 2, right? Of course. And then you'll say the 2's will cancel out. So now you have 16 over 5,000. Okay. But if you still want to simplify this further, you can just say, well, 16 can be written as 8 times 2 and 5,000 as 2,500 times 2 as well, all right? And then you can easily say, well, the 2's will cancel out. So you have 8 over 2,500. But if you are still not convinced, you can just say 8 can be written as what? Well, as 4 by 2, right? And 2,500, well, 25 divided by 2, it's 12.5. So this is what you're going to say. So it means, yeah, it's going to be 1250 times 2. And so these two will cancel out, okay? But if you're still not convinced, then you can simply say, well, 4 is 2 by 2. And what is 1250 divided by 2? Okay, what is 125 divided by 2? It's actually going to be, what is it? What is it? What is it? Let's see. 62.5. So you can say we have 62.5, and then you multiply this by 2, right? Yeah. Yeah, you can say that. And then you'll say, well, these two will cancel out. So what? So now you have 2 over 625. Okay. But we still need to take this further again because we still have, what is it we have? I don't know, but we need to take it further because if it's here, we are not really convinced that this one is actually greater than that one. So we need to be sure. Well, 2 is just going to be 1 by 2. And what is 625 divided by 2? Let's see. 625 divided by 2, 625 divided by 2, 625. Well, it's just going to be 312, and then you say 0.5. And of course, you multiply this by 2. Okay, so what? So 2 and 2 will cancel out, and now you are left with 1 over 312. Okay, it's 1 over 312.5. So the question then is, between this one as well as this one, which one is actually greater? So now it's time to compare the denominators, right? Well, here you can see that this denominator is very large compared to this one. For the same numerator of 1, it means this one is going to be less than that one. Sure. I think I might have made a mistake when I first said this one is going to be greater than that. Yeah, no, I was wrong, guys. I was wrong. So, yeah, this one is actually smaller than that one. So now that we have proven beyond reasonable doubt that 1 over 200 is greater than this, then it means something negative added to something that is larger than it. It's going to give us something that is positive. But you don't need to stress. In the exam, they won't give you something that is as complicated as this one in terms of simplifying it. So this is what we tell them. We say, well, since the derivative changes the sign, in other words, since the derivative is negative for values of x that are less than 80, but you need to say greater than 0, remembering the domain, right? But, or you can say and, the derivative is positive for values of x that are greater than 80. What does it mean? It means we have an absolute minimum at x equals 80. So now you have proven beyond reasonable doubt that indeed the value of x that we got is at the absolute minimum. Thank you so much, guys, for watching. And I'm really sorry for making this question, which is easy, to be extremely long as it was. I'm really, really, really sorry. I hope you find it in your hearts to forgive me.